Hello, everybody. Welcome to my session. I'm David Pilato. I'm French, as you can hear maybe. And I have been working at Elastic for more than 9 years now. Today, I'm going to speak about how you can add Elasticsearch for your legacy application. This is a talk based on my own experience when I was working for the French customs, and I went through several steps to make sure I was able to index my content into Elasticsearch and be able to provide a search engine on top of my application. So this is exactly what we are going to cover today. Tomorrow I will have another session, by the way, about how you can index your Office documents with Elasticsearch. So feel free to join me again if you are interested in that matter, actually. So I have been working at Elastic, and at Elastic we are providing a solution on a stack named Elasticstack. It's based on Elasticsearch. So Elasticsearch is the center of the stack, the heart of the stack. This is where you want to send your JSON document. The JSON document will be indexed, and you will be able to search within a blazing fast response time. And you will be able also to compute analytics on top of the result set. So we are going to cover that today. On top of Elasticsearch, you have Kibana. So Kibana is a UI on top of that, where you can understand what data you have. Today, we are going to use Kibana, but only to send some command. Instead of using curl, we are going to use Kibana and the dev console in Kibana to make sure we can discuss with our Elasticsearch cluster in an easy way. And then there is an integration layer where you can basically collect data from a lot of sources, like, for example, Apache logs, if you wish. And for that, and with that, you can build some solutions like observability on top of Elasticsearch, security analytics, and detection and response, things like that, with the stack, and also a solution named Enterprise Search with all this stack. So I'm Dadounet on Twitter. If you want to follow me, don't hesitate. After the session, I will share with you the information, and specifically, I will share the GitHub repository I'm going to start from. So here I have a code running, and I will go through several steps, and all those steps, you can find all those steps here. So if you want to compare one thing to another, you can just compare the steps, and then you will be able to see what changed between the branches. So that's here. Also, I created a blog post, and so you can also find that on our website if you want to again watch that again. That's the same story. So what do we have? We have an application which is running in Java here. So my application is basically managing people, and I have an entity domain here where I have a person, as you can see, with a gender field, a name field, the date of birth, number of children, and also I have an address, which is set like this. I have a country, the city, and the location, which is a geopoint with latitude and longitude coordinates. And also I have a marketing table, so this is more marketing data that I want to share here. So marketing counters, that's it. I'm using Hibernate here behind the scene, and Spring as well. And with Hibernate is automatically generated this schema for me in the MySQL database that I have here. So a table for person, a table for address, and a table for marketing data. So easy. I have started already the application. So the application is running in the background. And what I can show you is that I have here a search engine. This is the purpose of the talk. We want to search for here for people. And obviously, if I'm searching for something, I have nothing because I did not index anything yet. So to index something, I have here a generator. This injector is basically generating a random person. And once those people are generated, it's sent to the database. So let's inject and generate 1,000 people, for example, and send that to the database. So while this is sent, I'm not sure it's going to work immediately. So yes, we have to wait that the batch has been processed here. So we will see in a moment how long it takes. But for now, what we can look at is the code itself. So anytime we want to save a collection of persons here, we are using this person repository. And the person repository is something provided by Spring here, which is using Hibernate behind the scene. And in this repository, we have all the elements that we need to have, like how to save an entity, how to get an entity by the ID, and also a way to generate some queries, for example. So let's see. Yeah, it's done now. Oops. So here, for example, I have my 1,000 entities, as you can see, and this is the result set of my search engine. If we look at the numbers, we have been able to inject around 34% per second. So it took us 30 seconds or so to inject 1,000 person in my database here. The database is running locally, by the way. So we have a search engine, and we can search. We have a search like Google here. So I can search for on the name, for example, for Joe here. I can search for Smith, why not? So this is working very well. I can search for a city, why not? Paris. So here I can see all the people within a city. If I look again at the source code, if we look at the search method that we have, so this one, so basically what I'm doing, if the user did not enter anything from the interface, then I'm just getting all the result sets. So find all. This is provided by the person repository method. And otherwise, if the user has entered anything, I'm using this find like Google method. And this find like Google method is implemented like this. So this is a simple query here where I'm selecting all the person. I'm doing a join as well with the address table and the marketing table. But here I want to search within the name field for whatever the user has entered using this like person strategy. And same for address.country and same for address.city. So that's the reason it's working on address.city and name, because I'm using this like person thing. So what is the problem now? Do we have a problem actually? So I said I can search for Joe Smith. That works very well. But now let's search for Smith and Smith Joe. Smith Joe does not work because the way it is implemented, I need to have the first name and the last name in the right order. What I could do actually is to split what the user is searching for at the space and generate 2 tokens. And then instead of searching for 1 token, I can search for multiple tokens and change then the way the search is implemented. Okay, so this is not working here. Very good, very good. Okay, so if I do a typo like gsmo, for example, it does not work. There are multiple ways to solve that in a SQL world. I will show you in a moment how you can solve that super easily with Elasticsearch, but here you have to do something, right, to change that. Also, let me search for, so I said city. I can search for country as well. So let's search for France, for example. So what can we see? We have some people from France and we have someone from Italy, right? So this is not an issue because France is in the name field. So that's correct. But I think that for my use case, because France in the name is something which is super unique here, and probably also because I'm searching for people, so name field has more relevance if it matches on the name field than on the country field, then I would expect to have France on the first position. Here, I'm super lucky because France has been indexed in the second position, so I'm able to see it. Otherwise, if I was looking for someone called France and it was not in the first page, I would have to scroll over the pages to be able to find the person I'm looking for. So what I'm telling you here is about relevancy, right? So relevancy is the key point of a search engine. When you are using a search engine every day, like on Google, for example, You don't want to navigate through the pages. You expect to have the most relevant information on the top of the first page. And this is what we would expect with a normal search engine. I want to show you something else before we move to the code part. I have also this advanced search here where I can explicitly search within a name field, a country field, and a city field. So for example, if I'm searching here for Joe, living in France, living in Paris, for example, then I can see the information I'm looking for. Let's have a look at the code for this one. So the code is basically here. So from the interface, I'm calling this advanced search with the name, country, and city information. And then I'm building an example of what I'm looking for. And I'm using this example to find all the relevant person I'm searching for. Basically, this is the same thing. Okay, so now we have seen that we have some issues, and we want to fix that and use a real search engine to search, actually. So how are you going to send the data from the database now? So this is an important thing to have in mind when you start with a project like this. So the first idea, that was my idea when I discovered Elasticsearch as well, is to actually read from the database every, for example, 5 minutes or so using an ETL. It can be Talent, it can be Mule ESB, it can be Logstash. And every 5 minutes or so, when you are going to read the database and index all what you have in the database into Elasticsearch. So read from the database, transform to JSON document, send that to Elasticsearch. But what are the problems here? First, we are not in real time. I said, okay, let's run this batch every 5 minutes or so. It means that when someone clicks on the save button in my application, you will have to wait up to 5 minutes before this information is available for search. Okay, so we want to fix that kind of thing. And then the question you might have to ask yourself is, after 5 minutes, what I'm going to get from the database? I am going to get, again, everything, all the records, or should I only get a subset of the records that are available? If I want to have a subset, then I need probably to add a technical field in my database, which is a date, and then maybe just get what has been updated since the last run. Same for deletes. How you deal with deletes. You need to be aware that something which is not coming back has to be removed in Elasticsearch, which is not something easy. Again, you can do that maybe with triggers, or you can do that by using, for example, a technical table where you are going to write all the IDs that needs to be removed from Elasticsearch. Okay. So the best way for me, and I ended up with this solution, is actually to modify the application service layer and send the data to Elasticsearch at the same time in the same transaction as you are sending the data to the database. So this is what we are going to do now. So the first thing I need to do is to actually add our Elasticsearch connector. So here I'm going to use, I'm going to add Elasticsearch. So I'm not using the latest version of Elasticsearch. I will upgrade this talk anytime soon. We have released since then the version 8 of the project, but I'm not ready yet. So the client I'm using, it's kind of deprecated, but you will find the same philosophy once you move to the new client. Yeah. So I have my client available. So now what I can do, I can modify the person service. And when I'm saving here a collection of people in the same transaction, as I said, I can here call the Elasticsearch DAO class that I need to create. And I want to call a save method. I need to create as well. And I want to save all the persons that has been inserted in the database. So we need to create this field. So that will be a final Elasticsearch DAO class, which does not exist yet. So we can create this class. in the DAO package here. So I'm using Hibernate, I'm using Spring here. So I can just annotate this as a component, and that will be then easy to actually inject that into the constructor of the service here. Okay, so I have my Elasticsearch DAO class now. So we now need to implement this save method as well. So let's create that. And we want to index the persons here. Okay. I don't like this indentation. I don't know why. It's not indented the right way. Okay. So what do we need to have here? We need to have a client. So the client, Elasticsearch is provided with this, the dependencies I added is the REST high-level client here. So let's call that the ES client. And I need to initialize that in the constructor here. ES client. Let's do that here. So I'm not going to write the code, but basically what I'm saying here, so I'm giving here the cluster URL. So I will be running everything on the cloud service that Elastic is providing. You will see that in a moment. In the repository I shared with you, you have also a Docker compose, so you can run all that locally, but here it's much easier to use the cloud instance. Everything has been set for easy. So I can add the credentials here because everything is secured by default on cloud. And then I'm building here my client with all this information. The first thing I can do once I have my client is to call again my client, sorry, and call the info method. Info method is just going to ask information about the cluster which is running. And we need to provide here an option, request option default. So this can generate an error. So let's send that here. And this is returning info response. And with that, we can say, okay, so let's log this information. So, oh yeah, I need a logger here. So let me add the logger. Import, yeah, this one. So here I can log this as an info that we are now connected to this cluster running version. So the cluster is the cluster URL. And the version, we can get that from the info and get the version and get the number. Okay, the version number. Okay, we have that. So we are all set with the constructor, almost all set. What we need to have also here is to provide an object mapper coming from the JSON library that will help us to serialize our bins, so our person bins that we saw previously, to JSON document. Remember that Elasticsearch picks JSON, so we need to send JSON documents to Elasticsearch. So let's add a private final object mapper here, call that a mapper. And this is actually provided automatically out of the box by a Spring, so we can just inject that here. So once we have that, and yes, so I have my mapper here. So once we have that, I can implement this save method now. So what I'm going to use what we call the bulk API. Instead of sending one document per one document, this is something that you can do with Elasticsearch. There is a much more efficient way of sending documents. And because we have a collections here, we are going to send all the collection at once. So for that, we need to create what we call a bulk request. And this will be a new bulk request. And we want to send all the documents within the same index named person. So Elasticsearch is a multi-tenancy service where you can send multiple and different data to different indices. Sorry. So now we have that. So let's iterate for our persons here. So for each person, we have a person here. What we want to do? We basically want to add and generate a new index request and add that to the bulk request. So let's generate a new index request from Elasticsearch. With this index request, we can define what is the ID of the document. For a good practice, actually, because we are coming from a database, is to use the same ID that we have in the database with Elasticsearch. So with that, you can easily spot when you are missing entities in one place and if you want to compare to the other. So that's a good practice, in my opinion. So I'm going to use the person ID as a string that I have here. And the second thing I need to do is to actually send the JSON document itself. So I'm going to provide that as a source document. I'm going to use the mapper I mentioned before, and I can write the value as bytes. It can be string, but it can be also a byte array here. So let's use that. And with the object I want to serialize, and that will be a JSON document that we want to send. Okay. I can have an exception here, so let's try catch this. And if I have an exception, we can log, say something logger 1 and not serialize to JSON. Why not? And remove the stack trace. Okay, so I have this index request. So now I can add this to the bulk request. So I can add this new index request. So let's make that easier to read here. And that's good here. So I have added to the bulk request a new index request. So for each person, I'm doing that. So now I can call my client. So let's use the ES client that we have and call the bulk method. And we can provide the bulk request. And we need to provide also some options here, the default one. So here we can have an issue with that. So let's send that to the caller. Why not? This can return a response, bulk response. So what can we do with that? We should check, actually, if there is any error. So if we have a failure, we can check the bulk response as failure here. And if we have that, we need to do something here. I'm not going to manage that here, but you need to think that maybe for some entities, you will have to look at the logs or send that to a message queue system or whatever. So here I'm going to say we got a failure. And in the client, there is a nice way to build the error message, which is basically to use the bulk response and build failure message. And that's all. Okay, so let's compile that. So if you have any question, don't hesitate using the chat while I'm speaking to ask your question. So here, we can have an exception, as you can see here. Okay, when we save the entities to Elasticsearch, we can have an exception. Like we cannot communicate with Elasticsearch, for example. What can we do in that case? We can just throw the exception back and expect to roll back actually everything that has been sent to the database. That's a strategy. What I prefer to do, and this is what I implemented again at the French Customs, I prefer to catch the exception and say, if I have anything going wrong here, I have to decide. Actually, I don't want to roll back the transaction within the database because to me, what is super important is when a user click on the save button in the application, the data is actually saved in the database. Whatever is happening with the search engine, the search part is less important than saving the entities in the database. So here, what I'm just doing, I'm saying, okay, let's call the logger and say error and Houston, we have a problem. So use meaningful message like this one. No, I'm kidding. One of the other things you can do, and this is what I did actually, you can send the entities or all the entities here which are failing to a message queue system. And when Elasticsearch is back again, read the message queue and process again all the missing entities, basically. Okay, so I have done here for the save method. I just want to show you, I won't exactly run it during the demo, but I want to show you how you can deal with deletes. So in the delete method from the service, when you delete and you remove an entity from the database, you can also call the DAO of Elasticsearch and say, okay, I want to remove the same ID here. Why not? So we need to create this method. And here, I'm not going to use the bulk API. I could use the bulk API also for deletion, but here I want to show you how you can use a simple operation. So this is, you use the delete request, and what you have to provide is the index name, so the person, and the ID of the document, which is a string here, and the options. Okay, and this can generate an exception again. So basically, I think I'm all set with that. So what I'm going to do, I'm going to compile, and I'm going to restart. So let's restart the application. So we will see in a moment, hopefully everything running. So let's check the logs. Okay, what we can see here is that we are connected to a cluster running this version. So let's have a look at the cluster itself. As I said, I'm using here Elastic Cloud. And in Elastic Cloud, I have multiple deployments, which means multiple clusters. And here I'm using this legacy one, where basically this one is running in Belgium, where I have here a master node. I have also a data node, and I have also Kibana running, basically. So everything has been set for me. I have automatic backups. I can do upgrades with one click and things along those lines. So everything is set for me. So let's open Kibana here. So you might know what Kibana looks like. So I have Kibana. And here, what I want to do here, I want to go to the dev tools. So if I'm running get slash, I basically have the same information as when I called the info method in my Java application. And what I have been able to collect was the version number. This is what we are seeing here. Yeah, so the question is, so I have a question. Does this mean you are dealing with eventual consistency similar to the logstash solution? Yes, indeed. This is similar. There is no transaction in Elasticsearch. So at some point it will be consistent, but it might be not consistent yet while you are still indexing your document inside Elasticsearch. I'm going to check here. So for now, I don't have any index name person. This is what I'm looking for. If I'm running a search here, I can see that I have no index name person. So to have data, I need to index again, let's say 100 documents now, here in the database and in Elasticsearch at the same time. If I go to DevTools again and do that, so I see now that I have my 100 person in my cluster. Can zoom in again. And if I search for people and for everything here, what I can see, I have 100 documents, and those are the first documents that I've been indexed. So here I have my Joe Smith, date of birth, mail, etc. So this is the JSON representation of my entity that is also saved in the database. So we are good so far. If I go to search here, if I'm searching for something, I'm still using the database. I did not change the implementation on the database parts yet. So let's do that now. Let's change this. So in the person service here, I'm going to remove this SQL implementation and replace everything with the Elasticsearch implementation. So what I want to do here, I want to create a query. So for that, we have a query builder in Elasticsearch. And if the user did not enter anything, strings that is empty. So if the user did not enter anything, we want to run a similar query that we ran on the database previously, which is a match all query. So we have the query builders class here to help us building our queries. And here I can use the match all query here, which means give me everything that you have. Otherwise, the query I want to build is another one, builders. And I want to use here a multi-match query. What I'm searching for, Q. In which field I want to search for? I was searching within the name field, within the address dot country, and address dot city. And everything is indexed in Elasticsearch by default, so I can search also in the gender field if I wish. Let's do that. Okay, so I have my query ready now. So I need to call my Elasticsearch DAO and add a search method and provide the query here. And I want to show you how you deal with pagination. So you can basically provide the from and size parameters here coming from the interface. Size is the size of the page, and from is the it number you want to start from. And I need now to create this search method in my DAO class. So to do that, I need to call the ES client, do a search, create a search request. So I can search across multiple indices at once if I want to, but here I want just to narrow to the person index. So I'm going to search my data within the person index. I need to provide the option again. This can generate an exception. Okay, and now I need to provide more options. So define what we call the source. So a new search, what's the name? Search source builder. Exactly. And with that, yeah, I can provide what is the query. And for the pagination, it's super straightforward. I have the from and size parameter, so it's super easy to deal with that. Size and size. Another thing I want to add here, this is an option. By default, there is an optimization in Elasticsearch. After 10,000 hits, the Elasticsearch will just tell you that there is more than 10,000 results that match your query. So here I want to have the exact number. So I want to track the exact total hits that I have. So I need to remove that optimization. So it will be slower, I would say, but you won't notice that as you will see in a moment. Okay, so I have this search, and what I want to do now is to return this actually and make that return the search response. And in the person service now, what I want to do is to get this response object And what I'm going to do, everything has been done in the front end, so I'm not going to touch the front end today. This is a backend talk, basically. So I'm just going to send the JSON version of this response object, and that's all what I have to do. Okay, so we are done, I think, with the normal search. So let's do the advanced search and replace all that again with the Elasticsearch implementation of the advanced search. Remember, the advanced search, we have 3 fields within a form, a field for the name, a field for the country, and a field for the city. So to do that, I'm going to use this shortcut. Basically, I'm building again a query. And if I have nothing in name, nothing in country, and nothing in city, then again, I want to build a match all query. Otherwise, I'm going to build what we call a Boolean query here, bool query. And if I have anything in the name field, it must match on the name field within my Elasticsearch document. If I have anything on the country field, it must match on the address.country field. And same goes for the city. So it's easy to read. And then I'm using exactly the same search method that we implemented before. So let's restart the application again and see what is happening now. Okay, starting again. So we are connected still to the database. So let's have a look here at the search again. So let's search again. Is there a way to turn off this optimization regarding the total hits when sending queries as JSON directly against an ES instance instead of using the query builder programmatically? Yes, so when you are using that programmatically, this is exactly the same thing as providing within the JSON document that you are sending to Elasticsearch, the track total hits field value. So you can do that, definitely. So if we search again, so if I'm doing that, so here I have still my total number of hits. And if I'm searching for Joe, so it does not work, as you can see. But Joe, the full term is working now, not part of the term. So this is something we need to fix. I'm searching for Smith, it works. I'm searching for Joe Smith. Okay, it works also. If I'm searching for Smith, Joe, that works now. Okay, so I have something which is good. I said that I can search for the gender field. Okay, it works. Let's search for the country. As you can see now, France, Gal, this entity is on the top of the list. This is the most relevant document that we have. And you can see that here with this score, which has been computed on Elasticsearch side, which computes a score, the relevance scoring, relevant score, sorry, which is based on the rarity of a term within a field, and a lot of information matters here to compute the score. I'm not going to cover that in details. What is the name of the field to set it to true? This is track total hits. That's the name of the field. Yes, thank you, Daniela. So here I have my France on the top of the list, which is super cool. If I'm looking at the advanced search and search here for Joe, so it does not work. It works only for the full term, right? If I'm searching for France, does not work. But here it's working for the full term again, and Paris, same goes for it. So this is something we need to fix here because it's working partially. So why it's working partially? So here, so yeah, so to answer the question that I had in the chat, the property that you need to use is this one, track total hits. You can use that in the URL, or you can use that within the JSON document itself, as you wish. So why, when I'm searching for Joe, G-O, for example, it does not match? This is because of the mapping. Elasticsearch by default generates a mapping. you can get the mapping that has been generated by the Elasticsearch by default using this underscore mapping command here. And what we can see here, let's take the name field, for example. Where is that? The name field. By default, the name field, for the name field, we are applying a full text search strategy. And for that, we are using what we call an analyzer behind the scene. So we are analyzing the content that has been provided by the database at index time and also by the user at search time. And we are comparing both things. So what the analyzer is doing, by default, the standard analyzer is used here. There is a nice API named underscore analyze, which helps you to understand what is happening behind the scene. So let's have a look at this. If I'm analyzing Joe Smith here, this text, with the standard analyzer at index time, let's say I'm indexing Joe Smith like this at index, I'm indexing this text. With the standard analyzer, it's providing two tokens, GOE and Smith. Everything is lowercase, as you can see. So it's basically a break at the space. And here I have Joe and Smith, two tokens. But when I'm searching for Joe, we are going through the same analyzer. If I'm searching for Joe, GO is becoming GO like this. But GO does not match GOE. And that's why we are not able to find our documents. When a user is entering GOE, it works because this is providing this token, GOE. And if we compare that with the inverted index, we will have GOE in the inverted index. So that will match. Okay. So what we need to do? One thing you can do is to change the way the analyzer is defined. So here I'm going to provide an analyzer that I'm making myself. This is the ngram analyzer. For that, I'm using a specific tokenizer. I don't have enough time to explain all the details of the analyzer's process, but basically I'm using here an edge ngram with these settings. And you will see what is the effect of this edge ngram. When I'm analyzing Joe Smith now, what is going to generate at index time, it's not only Joe and Smith, but also G, GO, GOE, so subtokens. Same for Smith, S, SM, SMI, etc. Right? At search time, I'm going to use another analyzer, the simple analyzer, because I don't want to tokenize GO as G and GO. So with the simple analyzer, I'm going to basically lowercase everything, which means that if my user enters GO, it will produce this token, GO. And if I compare that with the inverted index, I will be able to find my text because it will be in the inverted index. So let's apply what we have seen. I'm going to remove the person index, and I'm going to create the index with the same ngram strategy that we just defined. And I'm going to apply that to the mapping. So I'm going to set the mapping to Elasticsearch. I'm not going to tell him, okay, do whatever you want. This is what I want you to do. What I'm going to do, I'm going to say, let's have a look at the name field again. Here, that for the name field, I still want to do full text search. So if I'm searching with name within the name field, it will only match with the full tokens again. If I'm searching now for the name.ngram field, it will be a full text search again, but now I will use the ngram strategy that we saw. I'm doing the same thing for the city fields. Here, I'm using this ngram strategy, and I'm also generating a city.keyword field, which is helpful for building analytics and doing sorting as well. Okay. And yeah, and this is basically what I'm doing here. So I have created my index person. So now I can reindex again some documents, inject. Let's see what is happening. Okay. If I'm searching again, checking that I have everything. So yes, I have my 100 documents again. So nothing changed here. And if I'm searching again for my entities, if I'm searching for Joe, it does not work, right? G-O-E. So only with G. G-O, not G-O. Only with G-O-E, not G-O. Why this? Because I did not change the search implementation yet. So here, instead of searching for the name field, what I want to search for is within the name dot ngram here. Same for gender, same for city, same for country, for example. And if I'm matching on the name field, what I can do, I can also boost the result by a factor of 3, for example, make it that more relevant if it matches exactly on the term here. So let's compile that and see what is happening now. Okay, if I'm searching again, here, search, if I'm searching again for G, O, so this time it's working, right? If I'm searching for France, but if you look at the score here, I have this score. If I'm adding the exact term, you can see that the score has increased a lot, right? Because I'm matching on both the n-gram and the non-n-gram transformation. So I have to do the same thing for the advanced search. GO does not match. But here, if I'm using the n-gram strategy, here I can do that, and do that. Okay, very good. So I have to do something else. I'm going to have not enough time, I think. So it's working now partially with partial terms. So that's what we were expecting. One of the other things I want to show you is that first we can index more documents in Elasticsearch, and we can be much faster if we are not calling the database. So let's remove here the call to the database here. And instead of saving our person from the database, I'm going to save here our persons only into Elasticsearch. So I'm just going to call Elasticsearch. And because we are not having an ID from the database, I'm going to remove the ID here. So let's compile that. And we will see that it might be much more, faster, much more faster than it used to be. So let's do 100. So it's done. Let's say 10,000. Okay, so 10,000, it's done again. So let's say 500,000. Okay, so it's much faster than it used to be, right? And while we are sending documents to the database, to Elasticsearch here, we can see here that our search is still working and in a very efficient way. What I want to do next, and I will probably conclude with that, I want to actually get more meaningful information from Elasticsearch. So to do that, I'm going to compute what we call aggregations. Yeah. So basically what I want to do, I want to compute the result set and break it on the address.country keyword field. So I have a count per country. And same for the date histogram here. So let's compile that. Everything has been done in the front end part. So it's easy to look at this now. If I refresh that, you can see here the result set of the result of my data set here, right? So it's super easy. You don't have to run a batch every night to perform those things. If I'm searching for Joe here again, you can see that whatever the number of documents that you have in some milliseconds, you have the number of Joe in total and the distribution per country or per 10 years, for example. One of the last things I want to show you, I won't have enough time to show you much more advanced computation. Here, I said that we want to be typo tolerant. So to do that, I can add here what we call a fuzziness factor. And with that, I can define to have a fuzziness tolerance, I would say. So let's compile that. Okay, and if I go here and I'm searching now for G smooth, you can see that I have my result set available, right, in a few milliseconds. Okay, finally, what I want to show you is that you can use Kibana for what it has been built for. You can build dashboards. So here, basically, I have a dashboard which represents my data set. So here you have the distribution per year, and then broken also per gender. The distribution here only per gender. So this is the result of the terms aggregation that we saw, for example. You can use the geo-coordinates to show that on a map if you wish, and things along those lines. And the power of that is that you can here search for Joe, for example, and then in some milliseconds, you understand what your Joe data set is built from, right? And you can navigate in the result if you wish, for example, and do whatever you want with that. So I think I'm running out of time. I'm done. So thank you very much for attending this session. I hope you enjoyed it. Feel free to join me tomorrow for the next session that I have. Have a nice day.